we'll have people popping in. Maybe Renaya thought was not her class. Okay, so let's look at some review from yesterday. So what is a wave? I'm just going to put this pole one. Okay. A, B, C, or D. Yeah, we're trying to test is 95% of all and there's like 16,000 tests, so that's pretty. All right, so good choice. Sounds like moving of energy and matter from one location to another, but remember what we were talking about was this one. Regular pattern of motion created by vibrations, a vibratory, right? All right. Hi, Kylie. Let's take a look at this one. Pole 2. Start a poll. This is pole 2. Pole 2. All right. Wave transfers what? Energy, matter, time, or A and B? What do you think? A, B. I can tell you it's not A or B or D. So if you weren't here yesterday, yeah, no, it's this one. Energy. Because matter, the wave looks like it's going to take like a water wave does look like it's going to take something over here, but those are the surface waves that are doing that. Surface waves do this, but the part that we're talking about is just energy moves like a stadium wave, just energy. All right. Excuse me. I did not swallow right. That's what happens. Can't talk and swallow at the same time. What statement below best describes the motion of a wave? Wave causes particles to spread out. Wave causes particles in the medium condense. A wave causes them to oscillate, right? So remember from yesterday, it was the oscillation that we're looking at. There we go. Got it out. So it's oscillation. Hey, Dylan. All right. So start a poll. This is poll 4. All right. Poll 4. Waves that are created by oscillations of electric and magnetic fields are called. Now that was from your exit quiz yesterday. Anybody do that yesterday? Remember what that was? Electric and magnetic fields. It's a strange thing. If you did the exit quiz yesterday, you got it. Yeah, there you go. Electromagnetic waves, right? And okay, so start to pull this poll question number 5. What type of wave produced the by moving or vibrating object? Right, so vibrating or moving object we talked about yesterday. It's not X-rays. It's not electromagnetic electromagnetic waves. Yeah, there you go. Letter A, right? Letter A, mechanical waves, what we were talking about yesterday. Hey, Carmen, good to see you. Jump in on these poll questions here. Just kind of reviewing for yesterday. Glad to see you guys. It is Tuesday. What kind of waves travel in space? Okay. So it's not this or this. It's either A or B. Which do you think? Travel in space. Yeah, yes, light waves, right. Hey, Adriana, good to see you. And Kendrick, good to see you as well. Happy Tuesday to you guys. Okay, so we're through with the the different types here. So we're going to record, and we're going to be talking about the different kinds here. So let me show you my slide deck here, because this one has some nice graphics, GIFs on it. Let me go to the slideshow here. All right. So there are three types of mechanical waves: transverse waves, longitudinal waves, and surface waves. All right. So if you can see, a transverse wave, like a water wave, is a transverse wave because the energy, let me get my pen working here. The energy is going to the right here, but the wave itself is going up and down. So it's perpendicular, or 90 degrees, remember 90 degrees, to the energy of the wave. Kind of reminds me of what we were talking about, work. Work being done has to be done in this direction of the force applied, but this is a transverse wave, is where the energy is going from right to left, and the energy of the size of the wave is going up and down. So the vibration of the matter, or the in light's case, we'll talk about that, but in case of matter, the matter is moving up and down. It's not transferring anything. So example of a rope, if you were to ever get like a jump rope and tie it to a string and then just kind of wiggle it really fast, you can make a transverse wave. Now, longitudinal waves, now how I remember longitudinal waves, they are long. And when I think about they're going in a long direction, they're not going up and down, their compressions, and they call them rarefactions, are going in the same direction. So the compressions are where the lines are close together, they're compressing, squeezing, and the rarefactions are when the wave passes, it opens up the space a little bit. So they're in the same direction. And then you can do a slinky and make a longitudinal wave. If you've ever had a slinky before, they're a lot of fun to play with. They're a lot of fun to play with. And here's a slow motion of a slinky. Let me get my pen back off. So this is how you can make a slinky, compress. And you can see that in the slow motion, you're seeing it compress, and compress means the rings or the loops are closer together, and then as they go by, they spread out. So that is a longitudinal wave, right, going in the same direction as the motion or the energy. And then there are surface waves. A surface wave is a combination of longitudinal and transverse waves. The surface wave is called so they can travel along the surface of the medium, which, such as the land or water. So earthquake, only particles in the surface of the medium oscillate. So this is that particular motion that circles around and round, right? Combination of particles to move in circular patterns. All right, so let me do this for you here, quick. I'll turn this off. Not that one. I'm going to turn that one on again. This one. All right, so let's do this. All right, so I'm going to give you guys opportunity here to, anybody can write the words in here, type in the words here. Which one's longitudinal, which one's surface, and what one is transverse. So anybody can get in there and start typing. Pick one, and then somebody pick another one. Hey, DeAndre, good to see you. Dalton, good to see you as well. Better late than never, yeah, good to see you guys. So Adriana, what are you going to put in that one? So that starts with the letter T. I can tell you that. So if you want to type in the word that says T, somebody can do the other one. Anybody want to do the middle one and the green one, the yellow and green? And you guys all have access to the computer. So Guess not. Okay, so this one is, let me go side a little longer here. This one is transverse. If I get it to type now. Transverse. Transverse. So I kind of see that because the fact that it's trans in reverse. How I think about it as far as the perpendicular. Okay, and oh, good job, guys. And longitudinal, I think of long, and it's going along the same direction. Along the same direction. That's how I remember. And surface is a combination. I'm not sure how you can think about that one. Surface ones. All right. So if I go this way, I think I can do this. I can make it bigger. Can I make it bigger? Nuts. How about maybe you can do it? All right. So they make them small. All right. Not a problem. I thought I could do it. Thanks, guys. Transverse, longitudinal, and surface. Okay, so let's talk about wave properties. Describe how a wave looks like. So there's amplitude, wavelength, and frequency we're going to be talking about. We've got a lot of vocabulary words when we're talking about waves, right? What's that up and downy thing? That's an amplitude. How long is it? That's a wavelength. And how fast does it travel? How many go by in a second or a minute? That's frequency. So the best visualization of this is we use an X and Y axis. On the X axis, remember that's the horizontal across the bottom. That's time and or distance. So this is the horizontal for the horizon. So you remember seeing the horizon or the sunset. And then on the side is the wave height. So X is here, the Y is here. I know you guys have to reorient yourself. And then there's a line in the middle, which is an equilibrium line. That's like if this is a water wave and you're looking at it the side, when the water is calm and not moving, then it's just like glass. So it's this rest period where the water is not going up or down. So we have a crest for the top. The top is the crest, and we have a trough for the bottom. Trough. I usually think of the trough as the valley, or trough is where you feed your animals. You know, if you have horses and cows and so forth, they have these big troughs that they can feed into, right? So as the disturbance moves away from the area, the particles move downward past the rest point. A maximum downward displacement is called the trough. The maximum upward displacement, and you've had displacement. Displacement is the crest. Displacement we talked about is distance from the starting point to the ending point. So if this is the starting point and this is the ending point, that's what we'd call the crest. And then the trough is the starting point to the ending point. So just to kind of use the word the similar that we've used it before. All right, crest, trough, and equilibrium. A wave moves maximum displacement. That seems like that's the same. Okay, so I'm going to give you guys, let me have you get a couple people in here and somebody put a check mark where the crest is. So if you're looking at this, which part is the crest? A, B, or C? Put a check mark there. And at trough, where is that? A, B, or C? Okay, I could use another person to do equilibrium or amplitude. There's one person that got the crest as B. That's correct. Yay! C for correct. How about the trough? Anybody can do the trough? It's like the valley. The valley. How does that work? Excellent. Yep, trough is great. How about equilibrium? That's that resting point. Anybody know where the resting point is? You have D or A, D or A here. Okay, remember the amplitude is we didn't really talk about this. We were going to talk about this. We only talked about equilibrium. Let me put amplitude in there already. Anybody know where amplitude is? Yep. Okay, so you have one left. Kylie, where is amplitude? Only one left. If you want to put that letter in, that check mark there. Nope. Okay, go ahead, Chloe. You can put it in there. So this is correct. And the amplitude is the last one. Okay, keeps getting in the way. Yeah. You guys are doing it. Yeah. Okay. All right. Well, let me put it in for you. Sorry, guys. So we got those in there. All right. Just kind of glitching on here. So amplitude we're going to just talk about here. So a wave cycle is one that complete path. So one up and one down, right? So this is two wave cycles, one up and one down. So you have to have, so let's count this one together. Let me do a poll here. Start a poll. All right, so this is a typed one. This is poll 5, poll 6, I think, poll 6. Start a poll. So you've got 1, 2. So this is 1, 2. What do you think? How many am I going to count? 3. How many do you think I've got here? So if we're going to count the number of waves, okay. So how many total if I can continue on? All right. Yeah, that's right. There are 5. I can't write the last one in for some reason. There are 5 in there. I can get 5. Okay, that's 5 cycles, number of wave cycles. Thanks, guys. 5 wave cycles. All right, and the amplitude is the height of the wave, the maximum displacement, okay? And that's where the energy comes in. So we can have things that we can make a lot of waves go by fast, that's energy, but we can also put some intensity in it by its height. Okay, the maximum displacement from the rest position and measured in meters. All right, the mechanical waves amplitude is related to the energy. Waves with the higher amplitude carry more energy. Right, so the wave can be the same, but we can kind of like, you know, if you thought about it, amp is a word we'll use when we're talking about amplifying something. If we have an amplifier, we can talk louder or make the music come out louder. So amplitude is talking about the energy as well. Hey, Journey. So to determine the amplitude, we measure in meters. Do not measure the distance from trough to crest. That's a little bit different here. Okay, so what is the amplitude in this particular one? So start, this is poll 7. All right, so A, B, C, or D. Okay, so is it height of the wave, the length of the wave, speed of the wave, or number of wave cycles completed in 1 second? So which one is that? A, B, C, or D? All right. Anybody else? Got one so far. All right, speed of the wave. We haven't talked about that yet, not speed of the wave. B, the length of the wave. We haven't talked about that yet either. And number of cycles in a second, we haven't talked about either. So what's left? There you go. All right, there you are. So letter A. Okay, now wavelength can be measured any place. We can measure it from the top to the top or the bottom to the bottom. Okay, so here is one complete cycle. So they went from where it hits the rest point to the other rest point. So one up and one down, as long as you have that. It's measured in they call it alpha or lambda, I'm sorry, and it's measured in meters. So the wavelength is something we have to measure. So this is 2 meters because they measured from 1 to 3. Okay, I usually go from here to here and it makes it a little bit easier to see, but the downward in here. So it's 2 meters, 1 to 3. All right, so let's figure out this one here. So let's do poll 8. And we're just about running out. We got about 3 more minutes. All right, A, B, C, or D. All right, so what do you call the region labeled A in the diagram? Is it amplitude, wavelength, frequency, or phase? All right, I got one person so far. Thanks, DeAndre. Thanks, Chloe. What are we going to call that? Thanks, Dalton. So if you're thinking about amplitude, amplitude is measuring up here. Here they're just telling us from this part to this part, one full cycle. Thanks, Kendrick. And this is the wavelength. Wavelength is how long it is on the x-axis. Amplitude is how high it is. Gets confusing. And frequency, the last thing we're talking about is the number of waves that pass in a second, and the word is hertz. It's named after somebody. All right, so not the people that rent cars, but HZ. So this one had two cycles in 1 second. So if you look at the end here, time is 1 second, and we get 2 whole waves that come by. So that would be called 2 hertz. All right, to determine the number of times a wave cycles. So this is the last question we're going to go into. This is poll number 9. All right, so. Okay, so this is the number of cycles is how often it happens. Okay, so I am frequently late to class is how many times you're doing it often, or I'm frequently early, or I'm frequently having breakfast at the same time. So yeah, this is frequency. Okay, so what we're going to do, right? So I'm going to have you guys practice a little bit on the cycles here. So I'm going to host a fishing frenzy for you guys on Blooket. So let me give you this link here. I'm going to clear the chat real quick and host this. It's got 7 questions. I'll give you 5 minutes. Here's a link for that. All right, get in there and do some practice. The exit quiz has got basically the same thing. Lots of the same kind of questions. So take your exit quiz. If you missed yesterday's exit quiz, make sure you do that as well. Thanks, Rachel. Thanks, Chloe. So this particular book, it talks about amplitude and wavelength. Okay, so hey, thanks Eddie and Adriana and DeAndre. So get started, ladies and gentlemen. We'll do some practice. All right, I'm going to pause this.